Hi, I'm Jan Ozer. Live webcasts are useful in a range of scenarios, from marketing to training to sales. But if you've never produced a live webcast before, you may think they're complicated, expensive, or both. Over the next few minutes, let's examine those perceptions when I show you how to produce a live webcast using Vuecast Niagara 2100 streaming appliance. I'll cover the gear and connectivity you'll need to stream the event, how to set up the Niagara 2100 and camera on site, how to configure your encoding presets, and how to create an active group that lets non-technical users start streaming by pressing a single button. Let's start with what you'll need. You'll need a camera, of course. I'll be using Canon's XH-A1 camcorder. You'll need a streaming appliance like the Niagara 2100. The unit is very compact and weighs only 5 pounds, so it's easy to carry and doesn't take up much space while on site. The 2100 is an entry-level live encoder that produces Windows Media VC1 streams compatible with the Windows Media Player and the Silverlight Player. An H.264 version for Flash will be available soon, and operation will be very similar. To stream the video live, you'll need to connect on-site to a network that's DHCP enabled. To distribute the video, you'll need a Windows Media server that can either pull the stream from the Niagara or accept a stream pushed from the Niagara. More on how to set this up in a moment. Finally, you'll also need a publishing point where viewers can access the video on the web or via a portable device, but that's beyond the scope of what I'll be talking about today. Let's get set up. Once you get on site, set up your camera as normal. Though Vuecast has live encoders that can stream high-definition video, to limit costs, the 2100 streams SD only, so configure your camera in 480i. Next, connect the camera to the 2100 using the highest quality connection. The Canon outputs component video, so I'll use that, though the 2100 also supports S-Video and composite input. Note that Vuecast supplies adapters to attach the RCA and S-Video connectors found on most video cables to the required BNC connectors. For audio, the 2100 can input either balanced audio via XLR or unbalanced audio via RCA connectors. I'll use the latter because the Canon doesn't output balanced audio. Now I'll plug the 2100 in and connect the Ethernet cable. In a moment, I'll configure the 2100 using another computer located on the same network. If no other computer was available, I could attach a monitor here and a keyboard and a mouse here and configure the 2100 directly. Not necessary in this case, so let's turn the 2100 on and create our encoding presets. Once you've connected the 2100 to a network, you can access it from any computer with access to that IP address, even remotely. I'm logging in from another computer on the same LAN, so I'll enter the computer name to access the encoder and then log in. Here's the Niagara 2100 control software. We'll spend most of our time in the encoder section, but let's briefly review the other areas. The configuration menu item leads to the Niagara 2100 properties window, alerts, and network properties, which is where you can find the IP address and associated settings. System configuration is where you set login parameters and an email address for designated alert conditions. Status shows the activity log and alerts. Back in the encoder's web page, you see encoders, active group, and groups. The encoders page contains all of your encoding presets. Here you see 3, the default encoder that ships with the Niagara and 2 other presets that I've created. For many live events, you'll want to create 2 streams. One high-resolution, high-data rate stream for LAN use, which is the 640 by 480 preset here, and a lower resolution, lower data rate version for internet distribution. That's the 320 by 240 version here. Creating an encoder is simple. Click Create New Encoder here and type in the name. I want to create a 480 by 360 preset to use instead of the 320 by 240 version. If you'd like to clone the properties from another preset, click this checkbox and choose the preset. I want to start fresh, so I'll leave it unchecked and click Create New Encoder. I'll start by choosing a Windows Media capture profile that matches the bitrate that my broadband viewers can successfully watch. While we're here, note the ATT Uverse PEG preset, which is ideal for producing public, educational, and government content for AT&T's UVerse service. But for my purposes, the Windows Media 9 at 768 kilobits per second should work well. Note that if I can't find an appropriate preset, I can create my own by running the Windows Media encoder directly on the Niagara 2100, but that's beyond the scope of this demo. Since I'm shooting in interlace mode, I have to deinterlace my footage. I'll use Motion Adaptive and accept the default settings of Smooth with a value of 16. If you had previously configured any digital rights management profiles, you could choose them here, but DRM isn't necessary for this event. Here's where I can choose to let a Windows Media Server pull the video stream from the Niagara or push a stream to my own Windows Media Server or a server hosted by a content delivery network. If you choose Pull, you'll need a different port for each simultaneous stream transmitted during a single session. The 640 by 480 stream that I'll use with this preset is configured to port 7007, so I'll use 7008 for this encoder. If I'm pushing the file out, I click Enable Push and enter the necessary parameters. If desired, I could save the file locally, but I don't want to devote valuable CPU cycles to that, so I'll ask the folks at the server facility to store and index the file there. When I'm finished configuring my options, I click Submit, which saves the profile. Now that we've set the data rate, I'll go back in and customize the other parameters. Here's our new profile. I'll click Edit and start working on the video and audio input settings. In the video input settings area, you need to match your inputs to your source video and physical connections. The only complicated selection is source, and then only if you're encoding multiple files simultaneously. That's because to create multiple encoders, the Niagara creates multiple virtual source files, so each encoder gets their own virtual source. I'll be using this preset with the 640 by 480 encoder, which I know is set to Video Device 1.1. So I'll set this to Video Device 1.2 so there's no conflict. Then I choose my input, signal, proportions, and size. Since I want 480 by 360, I'll choose Custom and enter those values manually. Then match the audio settings to the inputs. No virtual sources here, just choose the actual input. When I'm finished configuring these options, I click Submit again. Then OK. To start live streaming, I start the camera and then click the red Start button for both encoders. And off we go. To view the stream locally, I run Windows Media Player, click Open URL, and type in the encoder name and port. Wait a few moments for the video to buffer, and here it is. While you're streaming, note the CPU meter here. Typically you're okay so long as you're under 80%. In this case, while distributing two fairly high quality streams, we're only between 40 and 50%, which is plenty of headroom. To stop the streams, click Stop, and then Stop again. Now we have two encoders I want to use. Let's make it one button simple for our video people. Here's the Stream button on the front of the unit. When you press this button, it starts encoding using the active group of encoders. So let's create a group and make it the active group. Back in the interface, click Groups, and then Create New Group. Type in the desired name, choose the two encoders, and click Submit. When you create a new group, the Niagara makes it the active group, which you can change here. I'll leave Live Events selected. Next time the video folks take out the Niagara, they won't even need to log into the system. They simply plug it in, insert the Ethernet cable and audio and video connectors, and press the Stream button. The green light tells them they're streaming, and they can monitor audio using these meters, or insert a set of headphones. So that's it. The Niagara 2100 is small enough to easily carry around, but it supports high-quality component input, and if you can insert an Ethernet cable and press a Stream button, you can make it work. It's easy to pre-configure, but if non-technical users get into trouble in the field, you can log in and fix it from your office. So you see, with the Niagara 2100, live event streaming doesn't have to be expensive or complicated. Thanks for watching.